All right, 4.7 is the multiplication counting principle, also referred to as permutations. Okay, not a big deal. The multiplication counting principle, finding the probability of an event, often involves counting the number of possible outcomes of some chance process. Not a big deal. The Aragola restaurant offers a 3-course dinner menu. Customers who order from this menu must choose from 1 appetizer, 1 main dish, and 1 dessert. There are 3 options for each course. All right, you've seen this before. 3 choices of appetizers, 4 choices in main dish, 2 choices for dessert. How many different meals can be ordered from this menu? We could try to list all the possible orders if you wanted to. All right, so you could do this giant tree diagram, like starting with appetizers, you have 3 choices, and then after appetizers you have 4 choices on the main dish, and then 2 choices on dessert. Well, that's quite the ordeal to draw that out, right? And then if you count this up, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we came up with 24 possibilities, but there's an easier way. From the diagram, you can see that each of the 3 choices, there's 4 choices in main dish and then 2 for dessert. So it's basically, it's 3 times 4 times 2, which ends up at 24, which is what we counted at the end of the tree. 24 different meals can be ordered from the 3-course dinner menu. This is an example of the multiplication counting principle. For a process of involved steps, which is k number of steps, suppose that there are n ways to do step 1, n2 ways to do step 2, and nk ways to do step k. This is just generic math speak. The total number of different ways to complete the process is just the multiplication product of those options. The result is called the multiplication counting principle. This principle can also help us determine how many ways there are to arrange a group of people. Okay? Arrange a group of people, animals, or things. We call the arrangements where order matters. That's really important here. Order matters here. We call that permutations. Okay? It's a distinct arrangement of some group of individuals when order matters. It's important that you get that, because tomorrow we're going to look at something very similar, but order does not matter. So, for instance, suppose you have 5 framed photographs of different family members that you want to arrange in a line on top of your dresser. In how many ways can you do that? Well, count the options moving from left to right on the dresser. There's 5 options for the first photo, then there's only 4, then 3, then 2, then 1, and then you multiply them all and you get 120. So there's 120 different ways you could arrange those 5 photos. Now, expressions like what we just did, 5 times 4 times 3 times 2 times 1, where you start with a number and you count down to 1 and you multiply, occur often enough in a counting problem that mathematicians invented a special name, and we call that a factorial. And the symbol, notice here, is an exclamation mark. Okay? We read it as 5 factorial. So if you see a number that says anything factorial, just means you start with that number, you count down, keep counting down until you get to 1 and you multiply them all together. That's all a factorial is. So if it was 7 factorial, I would do 7 times 6 times 5 times 4 times 3 times 2 times 1. It's long, it takes time, but your calculator can help you, and I will show you how in class. Now, so far we have shown how to count the number of distinct arrangements of all individuals in a group of people, animals, or things. Sometimes you want to determine how many ways there are to arrange, select, and arrange only some of the individuals in the group. If there's n individuals, the notation npk represents the number of different permutations of k individuals selected from the entire group of n. All right, so let's say you had 5 photographs, but you didn't want to choose all 5, you chose 3. So n would be 5, you'd choose 3. Okay? So you can calculate the number of permutations or orders of 5 individuals taken 3 at a time using the multiplication principle or the formula n factorial divided by n minus k factorial. So if it was 5 and 3, it would be 5 factorial over 5 minus 3 factorial. So that's really just factorial over 2 factorial, and we'll crank out those numbers later, okay? Don't let this confuse you. The counting principle works just as fine, okay? Now, by definition, by the way, 0 factorial equals 1, if you ever needed to know that. Okay, so write that down. All right, let's try this. A standard issue 2014 New Jersey license plate had 3 digits followed by 3 letters, okay? So on the license plate, it has to be a digit, 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 and then 3 digits followed by 3 letters. Letter, letter, letter. All right. These plates were not allowed to have D, T, or X in the 4th position, or I, O, and Q in any position. Okay? So I, O, and Q can't be in these 2 spots. So we take 26 and we subtract 3. That's where we get 23 for each of those. But then in the 4th spot, you have to take away those other 3 letters. So that brings you down to 20 possibilities here. Now with digits, it's 0 to 9. Those are your digits. So that's 10 different digits, okay? And it seems like you can do repeats. It doesn't matter. So then you would multiply 10 times 10 times 10 times 20 times 23 times 23, and you get 10,580,000 possible plates. All right, suppose you have 6 assignments to complete in one night. How many different orders can you complete all these assignments? Well, it's just a factorial. So you just do 6 times 5 times 4 times 3 times 2 times 1. Because you have 6 assignments to start off with. Once you've done 1, then you only have 5 to choose from. And then 4, then 3, then 2, and so on and so forth. So it's just a factorial. And if you multiply that out, you get 720 possible orders to complete all of your assignments. Declan has 100 songs on his MP3 player. He's going for a run and has time to listen to 8 songs while he runs. But he decides to use the MP3 player's random shuffle feature to determine which songs will play and in what order. The random shuffle feature does not allow for any songs to be played twice. Don't worry about that. How many different lists of 8 songs are there possible? If he's got 100 to start with, if he has 8 songs to choose, how many different ways can we do that? Well, think of it as 8 blanks. 2, 3, 4, 5, 6, 7, 8. And we have 100 songs for the first, then 99, then 98, 97, 96, 95, 94, 93. You could also use that permutation formula. There's 100 choices, and we're choosing 8. Or different 8. How many different possibilities of 8 are there in 100 is what we're saying. So we get this nasty thing. 7.5 times 10 to the 15th power. So in your calculators, it's going to look like this, y'all. Has an E on it. That's what that means. That means like 15 zeros. 7, 5, and then 15 zeros. Okay, or 14 zeros, because you move that decimal 15 places. All right, so you're going to get big numbers for your answers, but don't be alarmed. That is normal. Okay? All right, I hope this helps, and we'll try this in class.